You are chewing right now. Or you were, 10 minutes ago. Breakfast, a snack, something between meetings. You did it without thinking. You have done it thousands of times today alone, and tens of millions of times across your entire life. And in every single one of those bites, something invisible happened inside your skull that you have never once been told about. Not in school, not by your dentist, not by anyone. Here is what actually happened. The moment your teeth pressed together, a force equivalent to 150 to 200 pounds per square inch shot upward through your jaw and into the bones of your face. That force did not stop at your teeth. It traveled through your temporomandibular joint, rattled the temporal bone at the side of your skull, and sent a pressure wave rippling through the fluid that surrounds your brain. Every single chew, every single bite. A mechanical shock wave directly into your central nervous system 3 times a day for your entire life. And here is the part nobody has ever told you. The side of your mouth where that force originates determines which half of your brain receives the signal. Not approximately, not loosely. The left and right sides of your jaw are wired into entirely separate neurological superhighways, feeding different hemispheres, triggering different nerve pathways, and activating different digestive cascades. They are not interchangeable. They are not the same tool. And you have been picking one of them completely by accident. Most people chew on the right. Not because it is better, because they are right-handed, because their right masseter muscle developed slightly more dominant early in childhood, and because nobody ever gave them a reason to think about it. The choice was made for you before you were old enough to question it, and your body has been quietly compensating for that choice ever since. The slight forward tilt of your neck on one side, the shoulder that sits a centimeter higher than the other, the afternoon fog that rolls in somewhere around 2 o'clock, the tension that lives behind your right eye. You have blamed stress, you have blamed sleep, you have blamed screens. The answer might be sitting in your jaw. What you are about to learn is that your mouth is not a food processor. It is a control panel, a mechanical interface that talks to your brainstem, your vagus nerve, your stomach, your spine, and your hips through a single, repeating, rhythmic action you perform without a second thought. And the left side of that control panel, for reasons buried deep in human neurovascular anatomy, does something the right side simply cannot replicate. This is not about chewing more carefully. This is not about slowing down at meals. This is about understanding that the most frequent neurological input your body receives every single day is the force of your bite, and that you have been defaulting to the wrong side of the equation. By the time this is over, you will understand exactly what happens inside the jaw during a single chew, why the left side sends a fundamentally different signal to the brain than the right, how that signal reaches your stomach before the food does, and what it does to the fascial chain running from your jaw all the way down to your pelvis. And you will have a simple, practical framework to start changing a habit that has been running on autopilot since you cut your first tooth. Start with the muscle, not the teeth, not the bone, the muscle. The masseter sits just below your cheekbone, angling down toward the corner of your jaw, and it is one of the most powerful muscles in the human body relative to its size. When it contracts, it does not gently press your teeth together, it slams them. The average bite force in a healthy adult runs between 150 and 200 pounds per square inch. Elite athletes and individuals with highly developed jaw musculature have been measured at over 265. To put that in terms you can feel, that is enough force to crack a walnut, compress a steel ball bearing, and send a shockwave straight up through the bones of your face, with every single repetition. And that word, repetition, matters more than people realize. You chew between 25 and 40 times per mouthful. A typical meal takes somewhere between 600 and 1,400 chewing cycles. 3 meals a day, every day, for a lifetime. You are not occasionally applying force to your jaw. You are running a mechanical pump thousands of times daily, and like any pump, the direction it pushes fluid, electrical signal, and pressure depends entirely on which side of the mechanism is doing the work. Here is what that pump actually does. When the masseter contracts and your molars meet, the force does not disappear into the food. It travels. It moves upward through the roots of your teeth, into the alveolar bone of your jaw, up through the temporomandibular joint, that small, disc-cushioned hinge just in front of your ear, and from there into the temporal bone of your skull. The temporal bone is not a fixed, rigid wall. It has a slight, measurable flex. It breathes, in an almost literal sense, responding to the rhythmic mechanical input of every chew like a drum responding to a strike. That flex compresses and releases the sutures between adjacent skull bones, and that compression wave moves fluid. Specifically, it nudges cerebrospinal fluid, the clear liquid that bathes your brain and spinal cord, through its channels with a rhythmic, predictable pulse. Your jaw is not chewing your food. Your jaw is pumping your brain. But here is where the left side separates itself entirely from the right. When your left molars come together, a specific chain of events fires that the right side does not trigger in the same way, through the same pathways, with the same downstream effects. It begins at the nerve level, and it begins immediately. Embedded in the periodontal ligament, the thin, elastic tissue that anchors each tooth to its socket, are mechanoreceptors, pressure sensors. The moment your left teeth compress against each other, these receptors fire, sending a signal racing up through the branches of the trigeminal nerve. The trigeminal nerve is the fifth cranial nerve, and it is the primary sensory nerve of the face. It has three main branches covering the forehead, the midface, and the jaw. Its mandibular branch, the one responsible for the lower jaw and teeth, carries mechanosensory data from your bite directly into the brainstem at the level of the pons. This is not a slow, meandering signal. It is a direct, high-speed electrical line into the most ancient and critical part of your central nervous system. Every time your left teeth meet, a fresh electrical pulse fires up that line. At a rate of 1 to 2 chews per second during active eating, you are sending somewhere between 60 and 120 individual electrical signals per minute into your brainstem, for as long as you are chewing. Now, pay attention to what happens next, because this is where it stops being anatomy and starts being something that should make you rethink every meal you have ever eaten. The brainstem does not keep that signal to itself. It routes it upward, and because of the way neural crossover works in the human nervous system, the same crossover that makes your left hand controlled by your right brain, stimulation originating on the left side of the jaw preferentially activates the right cerebral hemisphere. Not exclusively, not in a sealed, isolated way, but measurably, consistently, and with real functional consequences. Electroencephalography studies measuring brainwave activity during unilateral chewing have shown increased activation on the contralateral hemisphere. Chew on the left, light up the right. The right hemisphere is not the quiet hemisphere. It is the spatial hemisphere, the creative hemisphere, the one responsible for pattern recognition, big picture thinking, intuitive problem solving, and the kind of holistic awareness that lets you read a room, navigate a new city, or connect two ideas that seem unrelated on the surface. When you chew on the left, you are not passively nourishing yourself. You are actively biasing your brain toward its most integrative, expansive mode of processing. And there is a vascular mechanism underneath that neural one. The left common carotid artery, which branches off the aortic arch and travels up the left side of the neck to supply blood to the left hemisphere and face, is anatomically positioned closer to the mechanical activity of the left jaw muscles. Rhythmic contraction of the left masseter creates localized pressure oscillations that influence blood flow dynamics in that vessel. More mechanical activity on the left means more rhythmic vascular stimulation on the left, which means more consistent delivery of oxygenated blood to the left cerebral circulation, and through the interconnected architecture of the circle of Willis, that increased input supports perfusion across the entire brain, with particular benefit to the regions most directly supplied through the left carotid system. You are not just chewing, you are running a vascular pump in your neck with every bite. Now drop further down the nervous system, because the story does not stay in the skull. The vagus nerve is the longest cranial nerve in the body. It originates in the brainstem, exits through the skull at the jugular foramen just behind the ear, and descends through the neck, chest, and abdomen, branching into nearly every major organ along the way. It is the primary channel of the parasympathetic nervous system, the system responsible for rest, recovery, and digestion, and it carries information in both directions, from the brain to the organs and from the organs back to the brain. Here is something that rarely makes it into mainstream health conversations. The vagus nerve is not symmetrical. The left and right vagal trunks have different anatomical distributions and different functional emphases. The left vagus, as it descends into the chest, wraps more intimately around the aortic arch and contributes more substantially to cardiac parasympathetic regulation. The right vagus has a stronger influence on the sinoatrial node of the heart, driving heart rate. But in the context of the gut, the stomach specifically, the left vagal trunk is the primary driver of gastric motility along the greater curvature, the large rounded outer wall of the stomach, where the majority of initial acid churning occurs. When you chew on the left side, the mechanical and neural activity occurring in the left jaw engages brainstem nuclei that sit in close proximity to the vagal motor nucleus, the dorsal motor nucleus of the vagus. The rhythmic, repetitive input from left-sided mastication primes this nucleus toward parasympathetic output. It begins nudging the left vagal trunk toward activation before you have swallowed a single bite. This is called the cephalic phase of digestion, and it is one of the most underappreciated mechanisms in human physiology. The word cephalic comes from the Greek for head, and it describes exactly what it refers to: digestive preparation that begins in the head, before food reaches the stomach. The sight, smell, and taste of food all trigger cephalic phase responses. But so does the mechanical act of chewing, and the specific side of the jaw that is active changes the quality and magnitude of that response. Left-sided chewing, by engaging the left vagal pathway more directly, sends a preparatory signal down to the stomach that says the food is coming, get ready. The stomach responds by increasing production of hydrochloric acid in anticipation. The cells of the gastric lining ramp up pepsinogen secretion, the precursor enzyme to pepsin, which will begin breaking down protein the moment food arrives. The pyloric sphincter, which controls the flow of partially digested food from the stomach into the small intestine, relaxes slightly, adjusting its baseline tone for optimal throughput. The stomach is physically, chemically, and mechanically preparing itself while you are still at the table. When you skip this preparatory phase, or diminish it by defaulting to the right side, your food arrives at a stomach that is not fully primed. Acid output is lower. Enzyme concentration is suboptimal. The mechanical mixing process that the stomach performs, called churning, starts from a less activated baseline. The result is not dramatic enough to send you to a doctor. It is subtle enough to be invisible. Slightly longer digestion times, a little more gas. The vague, low-grade heaviness that sits in your chest after a meal that you have always attributed to eating too fast or too much. You were not eating too fast. Your jaw was sending the signal down the wrong channel. Go back to the skull for a moment, because there is something happening inside the bone itself that most people have never been told is even possible. The bones of your skull are not fused into a single, immovable helmet. That is what anatomy diagrams suggest, with their clean, locked suture lines drawn in tidy illustration. The reality is more dynamic. The sutures between cranial bones, the jagged, interlocking seams where one plate of skull meets another, retain a small but measurable degree of flexibility throughout adult life. They are not hinges. They are not joints in any classical sense, but they move, micrometrically, rhythmically, and in direct response to mechanical input. The temporal bone is the one that matters most here. It sits on the side of your skull, just above and behind your ear, and it houses the temporomandibular joint, where your jaw connects to your head. Every time your masseter fires and your molars meet, the temporal bone experiences a slight inward and outward flex at its squamous portion, the thin, curved plate that forms the side of your skull. That flex is transmitted across the squamosal suture to the sphenoid bone, a butterfly-shaped structure that sits at the base of your skull and articulates with nearly every other cranial bone in the structure. The sphenoid is sometimes called the keystone of the cranium, because if it moves, everything connected to it moves with it. When the temporal and sphenoid bones flex in response to left-sided chewing, they create a rhythmic compression and expansion cycle in the cranial vault. That cycle does something specific. It drives cerebrospinal fluid, the clear, protective liquid that surrounds and cushions your brain and spinal cord, through the narrow channels and cisterns of the central nervous system with a gentle, repeating pulse. The brain does not have its own dedicated pump, the way the heart pumps blood. Cerebrospinal fluid circulation depends on a combination of arterial pulsation, respiratory movement, and exactly this kind of rhythmic mechanical pressure from the skull bones themselves. Left-sided chewing, because of the anatomical positioning of the temporal bone relative to the jaw joint, produces a slightly more efficient cranial pump cycle on the left side. The temporal bone on the left has more direct mechanical coupling to the left masseter's force vector. The result is a more consistent, more rhythmic drive of cerebrospinal fluid through the left side cranial channels, washing metabolic waste products away from neurons, delivering glucose and nutrients to deep brain tissue, and maintaining the chemical environment that allows clear, efficient cognition. This is not a marginal effect. Cerebrospinal fluid clearance is now understood to be one of the primary mechanisms behind cognitive resilience and neurological health, particularly during the hours when the brain is actively processing information. Your jaw is helping run that clearance system. Every meal is a maintenance cycle for your brain, if the right side of the jaw is doing the work. Now follow the force downward, because it does not stay in the skull. The jaw is connected to the skull through the temporomandibular joint. The skull sits on top of the cervical spine through the atlanto-occipital joint, where the first vertebra, the atlas, cradles the base of the occiput. The cervical spine connects to the thoracic spine, which connects to the rib cage and the shoulder girdle. The thoracic spine continues into the lumbar spine, which sits on the sacrum, which is wedged between the two halves of the pelvis. And the pelvis balances on the heads of the femurs, the hip joints, from which the legs extend to the floor. This is not a metaphor. This is a continuous mechanical chain, and it is wrapped in fascia, the dense, interconnected web of connective tissue that encases every muscle, bone, organ, and nerve in the body in a single, unbroken sheet. Fascia does not compartmentalize, it transmits. A sustained mechanical imbalance at the top of the chain, at the jaw, propagates downward through that fascial web with the slow, relentless patience of a structural engineer's nightmare. When you chew predominantly on the right side, the right masseter, right temporalis, and right medial pterygoid muscles all develop greater tone and thickness than their left side counterparts. This asymmetric muscular tension pulls the right side of the jaw slightly upward and forward during rest. The skull compensates by tilting fractionally to the right. The atlas, carrying the skull, shifts its position to accommodate that tilt. The cervical spine introduces a compensatory curve. The shoulders follow, with the right shoulder typically rising slightly and rotating forward to balance the head's new center of gravity. The thoracic spine introduces a counter-rotation. The lumbar spine compensates below that. The pelvis tilts. One hip rises, the other drops. You have seen this pattern on people without ever knowing what you were looking at. The person whose head lists slightly to one side in photographs. The one whose right shoulder always seems tighter, higher, more guarded. The one who cannot sit evenly in a chair without one hip pressing harder into the seat than the other. You have probably felt it in yourself. That persistent knot below the right shoulder blade that no amount of stretching fully resolves. The neck that always stiffens on the same side after a long day. The lower back that torques slightly when you stand for too long. A chain does not break at the strongest link. It breaks, or distorts, at the point where accumulated unresolved tension finds its limit. For most right-side dominant chewers, that point is somewhere between the neck and the hip, and it started at the jaw. Now go to the surface, to the face itself, because the consequences of unilateral chewing are visible in a way that the internal ones never are. Bone is not a static material. It is living tissue, constantly being broken down by cells called osteoclasts and rebuilt by cells called osteoblasts. The balance between those two processes is not random. It responds directly to mechanical load. This is Wolff's law, established in the 19th century by the German anatomist Julius Wolff, and it states simply that bone remodels itself in response to the forces placed upon it. Load a bone regularly, and the osteoblasts respond, building new matrix to reinforce the structure. Remove the load, and the osteoclasts win by default, gradually thinning and weakening the bone over time. Your jaw bones, your zygomatic arches, your temporal bones, and the entire three-dimensional scaffold of your facial skeleton are subject to this law without exception. The side of your face that receives the majority of chewing force develops denser, better reinforced bone. The muscles on that side maintain their volume. The overlying soft tissue has better structural support. The side that is underloaded, the side that sits quiet while the other does the work, begins a slow, gradual process of resorption. The bone thins. The muscle atrophies subtly. The soft tissue above it loses support from below, and the architecture of the face changes in ways that are visible across decades, but invisible in any single moment. Facial asymmetry in adults is almost never purely genetic. It is mechanical. It is the written record of a lifetime of habitual, unilateral chewing, etched directly into the bone by the laws of structural biology. The face you have at 50 is partly the face you chewed yourself into. And because the left side is the one that most people neglect, the side that their unconscious habit has systematically underloaded, it is the left side that typically shows the earlier signs of volume loss, reduced projection, and subtle structural flattening. Chewing on the left does not reverse aging, but it does distribute the mechanical load that Wolff's law requires to maintain bone density across both sides of the face. It is the simplest, most frequent skeletal loading stimulus available to you, and it costs nothing but attention. Go deeper now, into the hippocampus, because this is where the story arrives at something that should genuinely change how you think about meals. The hippocampus is a curved, seahorse-shaped structure buried in the medial temporal lobe of the brain, and it is the primary site of memory formation, spatial navigation, and neurogenesis, the birth of new neurons in the adult brain. For decades, neuroscience held that adult humans could not generate new brain cells. That dogma collapsed in the late 1990s, and the hippocampus turned out to be one of the primary sites where new neurons continue to form throughout life, in a process that is sensitive to physical activity, sleep, stress, and, as more recent research has established, mastication. Multiple studies in rodent models and human observational research have now documented a clear relationship between active chewing and hippocampal function. The proposed mechanism runs through the same trigeminal pathway described earlier. Rhythmic mechanical input from chewing travels up the trigeminal nerve into the brainstem, and from there projects upward through the thalamus to the somatosensory cortex and into the hippocampal formation. Active, bilateral or left-dominant chewing provides a consistent, rhythmic stream of sensory input that stimulates hippocampal circuits associated with spatial memory and contextual learning. Studies measuring cognitive performance in older adults have found correlations between tooth loss, reduced chewing efficiency, and accelerated hippocampal atrophy. The jaw is not just feeding the body, it is feeding the memory system. Left-sided chewing, by virtue of its preferential activation of the right hemisphere and its more direct trigeminal projection through the left mandibular nerve, provides a targeted stimulus to the hippocampal regions most associated with spatial and associative memory. This is not a dramatic, immediate effect you will notice after a single lunch. It is a cumulative one, thousands of meals, hundreds of thousands of chewing cycles, each one either investing in hippocampal stimulation or quietly withdrawing from it. The direction of that account depends on which side of your mouth is doing the work. Which brings you to the only question that actually matters at this point. What do you do with this? The answer is simpler than everything that preceded it, which is often how the best answers work. You do not need to overhaul your diet. You do not need to change what you eat. You need to change where in your mouth you are eating it. The framework is called the 70-30 left chew rule, and it is exactly what it sounds like. For approximately 70% of your chewing cycles in any given meal, you consciously direct the food bolus to your left molars and allow the left masseter to bear the primary load. The remaining 30% you allow to fall naturally, without forcing symmetry or overcorrecting. The goal is not perfection. The goal is consistent, deliberate left side bias over time, which gradually rebuilds left masseter tone, rebalances the trigeminal input to the brainstem, and begins reversing the downstream fascial and skeletal compensation patterns that years of right-side dominance have accumulated. The practical method is simple. At the start of each meal, place your first bite deliberately on the left side. Chew it there for the full cycle before swallowing. Use that first bite as a reset, a conscious act of choosing which channel you are sending the signal through. From there, the habit begins to self-reinforce. The left masseter, as it is used more consistently, develops greater resting tone. The proprioceptive feedback from the left periodontal ligaments becomes more familiar. The brain begins defaulting to the left side, not because you are forcing it, but because the left side has become the structurally capable side. This is not a supplement. It is not a protocol that requires equipment, expense, or any change to your schedule. It is 3 meals a day, a small shift in attention, and the understanding that every bite is a neurological event. Every meal is an opportunity to either tune the system or leave it running on a default setting that was never chosen for your benefit. The jaw is the most frequently used joint in the human body. You have been operating it unconsciously your entire life. Now you know what it is actually connected to.